wanted to do a few more examples of factoring quadratics with leading coefficients that are greater than 1, just so that we can get a hang of the X box method. So I'm going to start by creating a big X, and then remember what goes in the top of the X is the A value times the C value. So in this case your A value is 6 and your C value is going to be -4. So what's going to go in the top of this X box is -24. And then what goes at the bottom of the X is your B value. And so the B value is this +5. So I'm going to go ahead and put 5 down here. And what you're looking for is two numbers that multiply to give us -24 that add up to +5. So this is where students can sometimes have some trouble where they're trying to think of what do they know are factors of 24. So I know that we can have 1 times 24, but if I were to add those together I'd get 25, and if I subtracted any of that, that's going to give me like 23. So that's not going to work. 6 and 4 will also multiply to give me 24, but if I add those together I'd get 10, and if I subtracted them I'd get 2, and so that's not going to give me the 5 that I'm looking for at the bottom. Let's try maybe 8 times 3. 8 times 3 will give me the 24, and if I have a negative sign on the 3, then that 8 minus 3 would give me the 5 that I'm looking for. So those are the two factors that I want, 8 and -3. So that's the procedure that you're going through, and then you want to create a box that's 2 by 2. And so in that very first square, we're always going to put the first term that we see in the original problem. So that 6x squared goes in the first box. And then in the last box, you're always going to put the last term, so that -4 goes in the last box. And then on the opposite diagonal, that's where you're going to put in the 8 and the -3. And it doesn't matter if I put the 8 in the upper corner and the -3 in the bottom corner. I just randomly selected where I put them. And we're going to put x's after these two numbers because this problem uses x as the variable. If they were using a different variable, you'd go ahead and put, if it was a's in the problem, you'd put a's after those two numbers. If it was z's in the problem, you'd put z's after those two numbers. So this is the setup. And then now we have to figure out how to break up the 6x squared so that I can still get the 8x and the -3x. And so what I mean by that is I can't just like put any old factors of 6x squared down. So like for example, if I put a 6x here and an x along the top, if I put a 6x here, how am I going to get a -3x in that box? It's not going to work. So I'm not going to choose 6x and x. I'm also not going to put 2x and 3x this way along the top of the box because 2x times what is going to give me the -3x? That's not going to work. And then 3x times what is going to give me the 8x? That's not going to work. However, those are the two factors that I want. I'm just going to switch up where I put them. What if I put the 2x at the top and I put the 3x at the side? Now I can think of a number that I would need to multiply 3x by to get a -3x. That would mean that I need to put a -1 along the top of the box here. And then for the 2x, I can think of a number that I would need to multiply by to get 8x. I would need to put a +4 along the side of this box. So that'll work. Okay, so +4 goes here. And then to double check, we always say what, I check that last box and see if I can get -4 by multiplying together this number and this number. +4 times -1 does give me the -4 that is in that last box, so this works perfectly. Okay, so for our final answer, we're going to have two sets of parentheses. And in the first set of parentheses, I'm going to put down the factors that are along the top of the box. So 2x minus 1. And then for the second set of parentheses, I'm going to put down the two factors that I find on the side of the box. 3x plus 4. So we fully factored that trinomial. Let's do one more. This one is 4x squared minus 19x plus 12. So we need to create our big X. And what goes at the top of the X is what I get when I multiply the A times the C together. So 4 times 12 gives me 48. That's going to go at the top of the box. And then what goes at the bottom of the box is what I get from the B term. So negative 19. So what I'm looking for are two numbers that multiply to give me positive 48 that add up to negative 19. These seem like tricky factors, so I'm going to think of numbers that I know multiply to give me 48. 1 times 48 will give me 48, but 1 plus 48 would be 49, and if I subtracted those, I get 47. That's not going to give me a negative 19. 2 times 24 would also give me 48, but if I added them, I'd get a 26, and if I subtracted them, I'd get a 22. That's not going to give me a negative 19. 3 times 16 is 48, and if I made both of those numbers negative, negative 3 and negative 16, those will multiply to give me positive 48, and they will also add up to negative 19. So those are the factors that I'm looking for, negative 3 and negative 16. Okay. So now I need to create my box. And in the first square of the box, I'm going to go ahead and put down 4x squared. In the last square, I'm going to put the 12. On the opposite diagonal, I'm putting down the negative 3 and the negative 16 and putting an x at the end of them. Okay, so now I'm at the place where I need to figure out how to break up the 4x squared. So I know that 2 times 2 was going to give me 4, so I could try to put a 2x along this side and a 2x along this side, but what would I have to multiply 2x by to get negative 3x? That's not going to work. So instead, I'm going to try 4x times x, because I can think of something that I'd need to multiply 4x by to get negative 16x. That's going to require a negative 4 along the top here. And I can think of something that I need to multiply x by to get a negative 3x. I would need a negative 3 down here. So now I'm going to put my two sets of parentheses together. Oh, I forgot to double check and make sure that that last square gave me exactly what I needed. So if I needed it to multiply to give me positive 12, I look back here and I go negative 3 times negative 4 does give me that positive 12. So this is working perfectly. Okay, so in the first set of parentheses, I'm going to put x minus 4. And in the second set of parentheses, I'm going to put the 4x minus 3. And we're all done.